In this video, we're going to talk about arcs, major arcs, minor arcs, semicircles, and a couple other things that have to do with circles. So first, in the past video we defined this, but let's look at it again. What is an arc? An arc is an unbroken part of a circle. So you pick 2 points on the circle, and the continuous unbroken part between those 2 points is called an arc. And the 2 points in between the arc that are called endpoints. So a segment has endpoints, so do arcs. There are 3 different types of arcs. You have a semicircle, which is exactly half of the circle. So a semicircle is always going to be 180 degrees. A minor arc is going to be an arc that's smaller than a semicircle, or an arc that's less than 180 degrees. And a major arc, I bet you can't guess what that is. Well, that's an arc that is larger than a semicircle. So it's an arc that's bigger than 180. When you name an arc, it depends on which type of arc it is. So if it's a minor arc, all you have to do is name it with 2 points. So if we were naming this minor arc AB, then we would just put AB with a little arc symbol above it, which kind of looks like the same way you would represent a line segment, but the line that goes above the points is slightly curved, like as it is right here. If we were naming a semicircle or a major arc, you would have to name 3 letters. So you name 2 endpoints, so A and B are the endpoints, on the end of the name, and then 1 point in between that would have to be in the middle. So that major arc on the right, could name it ACB. What would be another way you could name that arc? Well, you could also name it by saying, oh, BCA. And that would be the only other way to name it, because you have to make sure the endpoints are on the outside. If we named it, say, like CBA, CBA would be a completely different arc. CBA would look like that. So it's really important that the endpoints come at the beginning and the end of the name. And if it's a major arc, you use 3 letters. Alright, if I just clear this drawing real quick and made a new one, if I were to name that major arc just AV, then it would not be talking about the arc in green, it would be talking about this arc right here. So if you name it with 2 letters, it's going to take the shortest route in between those two endpoints. So here's another picture. We got a minor arc PD, less than 180, semicircle APD. We have to name that with 3 points, because if you don't, then you don't know what side it's going around. Like if I just said AD, it could be arc APD, the one on the top of the circle, but if I just said AD, it could also be talking about that semicircle, which are 2 completely different parts of the circle. And then again, major arcs, you name them with 3 points. And again, central angles, I know you saw it in the last video, but I want to talk about them again. It's an angle with its vertex at the center of the circle and sides passing through the circle, creating an arc. So, remember that the arc measure has the same measure as the central angle. So, since that central angle B and the center isn't named, so let's name it right now. Let's say that the center was called A. If angle BAC was 45 degrees, that means that this arc is 45 degrees. So right now I want you to think about what fraction of the circle is BC. Well, BC would be 1/8 of the circle, because it's 45 degrees of the entire 360. So 45 over 360 is 1/8. And the major arc BDC, well, since that minor arc is 45 degrees, the arc BDC would have to be 315, because we know that a full circle is always 360 degrees. Inscribed angles is an angle with its vertex on the circle and its sides passing through the circle, creating an arc. Inscribed angles are half the measure of the arcs that it intercepts. So again, I did this example in the last video, but if I just do it real quick again, if I had an inscribed angle that was 90 degrees, it would cut the circle approximately in half. Now right now I'm eyeballing it, but that's just a good example I think of when I'm trying to decide what's the relationship between inscribed angles and arcs. And if I made this inscribed angle 90 degrees, then the arc would be 180, so that means that the inscribed angle is always half the arc. So let's apply this to some problems. So if I was looking for arc AB, the only information I have to help me find it is the central angle that intercepts that arc. So since this angle AOB intercepts this arc AB, and AOB is 49 degrees, that means arc AB is also 49 degrees. And if we wanted to figure out the measure of ABC, this major arc right here, we would have to look at the central angle that intercepts it. Well, to figure out that central angle, we have to use the information that's given. So, since central angle COA is 107 and central angle AOE is 49, to figure out what this measure of this angle right here is, we'd have to do 360 minus 107 minus 49, and you'd get 204. So now, if I was just focusing on angle CBA, or as it's listed right here, ABC, I'm just going to add 204 to 49, which would be 253 degrees. Angle BAC, well, to figure this arc out, I'm just going to add the measures of arc AB and arc AC, which would be 49 and 107 respectively. So that would come out to 156 degrees. And then ACB, well, same idea. I would have to add the measure of arc AC and arc CB. So I would say it's 107 plus 204, so that would be 311. Alright, let's try another one. Now, with inscribed angles. So the only difference here is that you have to remember that inscribed angles are half the measure of the arc that it intercepts. So let's look at A first. Well, since we have a diameter right here, you need to know that diameters always cut circles in half. So on either side of the diameter is always going to be a 180 degree arc. So we know that from here to here is 180 degrees. So that means that angle A would have to be 30 degrees. For angle B, well, we know it's half the measure of the arc that it intercepts. So since it intercepts a 40 degree arc, we know that angle B has to be 20 degrees. And then angle C, since it intercepts an arc that's 30 degrees, would have to be 15 degrees. One more problem I want to do, actually a couple more, sorry I lied, but this problem looks like a quadrilateral inside of a circle, and it is. It's called the cyclical quadrilateral. Whenever you have a quadrilateral that has its endpoints on the circle, it's called the cyclical quadrilateral. Now, to solve this problem, we're going to use what we know about inscribed angles. So, first, I guess we could figure out what angle, well, let's look at this arc right here. This arc that I'm drawing in green. Since this arc that I'm drawing in yellow is intercepted by the inscribed angle 105, that means that that arc has to be double 105. So the arc in yellow has to be 210 degrees, because again, it's opposite an inscribed angle that is 105. And inscribed angles are always half the measure of the arcs that they intercept. So if what's in yellow is 210, and this angle right here is 110, then that means that this arc right here has to be 100 degrees. Alright, we can now use similar logic to help us find angle B. So, if I draw out this angle right here, that's 95 degrees, I know that it's going to intercept this arc right here, which would have to be 190 degrees, because inscribed angles are always half the measure of the arc that they intercept. So, by default, this arc... Wait, what happened? Cancel. I don't... Sorry for that. Oops. Alright, let's keep going. So this arc in orange is 190 degrees. So since this arc is still 110, that means that angle B has to be 80 degrees. All right. Now let's clear this because there's a lot going on. So now to help us figure out angle A, remember that we know that this arc right here is 100, and this arc right here is. So this arc right here is 80 degrees. Then we could figure out that this arc would have to be 360 minus 110 minus 100 minus 80. So it would have to be 70 degrees. So now to figure out angle A, well, angle A has to be half the measure of the arc that it intercepts. So since it intercepts a 150 degree arc, because this arc is 80 and this arc is 70, angle A has to be half of that. So it would have to be 75 degrees. And then angle C is going to be opposite this arc, which is 170 degrees. So angle C would have to be half of that, 85 degrees. Alright, now that was a really complicated way to do it, but nothing that you can't handle. Alright, all we did was use what we know about inscribed angles, but I want you to notice something, and this happens every time in a cyclical quadrilateral. Opposite angles in a cyclical quadrilateral will always be supplementary. Alright, so notice how 75 is opposite 105, and they add up to 180, and 85 is opposite 95, and they add up to 180. That's always going to happen because, if I exit the drawing one more time, if you look at two opposite angles in the cyclical quadrilateral, alright, look at this inscribed angle in green. It's going to intercept this arc in green. Alright? And then look at this inscribed angle in orange. It's going to intercept this arc in orange. Now, if you look at the orange arc and the green arc, that makes a full circle, 360. So both of these inscribed angles are opposite angles that add up to 360. And since they're always half the measure of the arcs that they intercept, since they're inscribed angles, they should add up to be half of 360. So that's always going to happen. So if you see a cyclical quadrilateral and you see that this is 95, you just say, oh, well, C has to be 85 because they add up to 360, and A has to 180, and A has to be 75 because it's opposite 105, and they're opposite angles in a cyclical quadrilateral, so they should be 180. All right. So again, opposite angles in a cyclical quadrilateral always are supplementary. And last but not least is the parallel lines intercepted arc conjecture. Now, if you look, this kind of reminds me of Donatello from Ninja Turtles. It's got the blue headband going on, green hat, but nonetheless, it is a circle with two parallel lines, and let me indicate that they're parallel by putting arrows there. And since I know they're parallel, I know that these two arcs will be congruent. So if I knew that this angle that I'm drawing right here was, say, 20 degrees, then this angle right here would also have to be 20 degrees. And in class, we'll look at that deeper. We'll do a little investigation and see why that happens. Alright, that's about it. Thank you for watching. I hope it was helpful, and have a good one.